Two fire stations are located 56.7 miles apart at points A and B. There's a forest fire at point C. If angle CAB equals 54 degrees and angle CBA equals 58 degrees, which fire station is closer? How much closer? So we'll start here with the diagram. So we've got two fire stations, A and B. And it says they are 54.7 miles apart, so there's the distance here. And then there's a forest fire somewhere at point C. I don't know exactly where C is. I'll just put it generically up here. And it says that angle CAB is 54 degrees. And angle CBA is 58 degrees. So there's my picture. And we're going to be using either the law of sines or the law of cosines. I prefer to use the law of sines. I think it's easier. And in order to use the law of sines, I need an angle-side pair. That is to say, an angle and the side opposite. So here I have an angle, but I don't know what the opposite side is. Here I have an angle, but again, I don't know what the opposite side is. Here I have a side, but I don't know what the opposite angle is, but I can figure out what that opposite angle is by subtracting the 54 and 58 from 180. So I'm going to fill in that missing angle because that will free me up to do the law of sines. So let's fill in over here. Measure of angle ACB is equal to 180 subtract 54 and 58. So that's 112, so 68 degrees. Okay, so we'll fill in the 68 degrees, and now that we've got this angle side pair, this opposite pair, we can use the law of sines. So let's start there. So we're going to do sine of the angle that we just found, 68, divided by the length of the opposite side, 54.7, is equal to, and then you take your pick. I'll do sine of 54 first, divided by the length of the opposite side. The opposite side is, well, we'll call it little a, because it's opposite capital angle A. Okay, so we'll cross multiply. And then divide both sides by sine of 68. And then we'll use our calculator to get an approximation here. Okay, and again, you hit any of those three trig buttons, you make sure you're in the right mode. This is a degree problem. So as long as we've typed that correctly, then we should have our answer for A. So A is about 47.7 miles from the forest fire. So that's over here. Okay, and in order to find side B, I'll put this one here in green. It's the same game. Again, I'll go back to the original numbers that I had. I had that pair, so I'll use that again. Sine of, in this case, 58 degrees divided by the length of side B. Cross multiply. Divide by sine 68. Type this in the calculator, second entry, and then we'll just change this to a, wait a second. Oh, we're changing the one that's on top. So this one right here just becomes a 58 instead of a 54. And that side is about 50 miles long. So that's over here. Okay, so then which fire station is closer? Well, apparently B is closer. And how much closer is it? About 2.3 miles closer. If we want the most accurate answer, probably should have saved this number, this 47.72. I'll type in a few of those digits. So about 2.3, that's close enough. So if we do B minus A, we get something around 2.3 miles closer. And we'll make sure we answer the question here. B is closer. Okay, the second activity problem is here. Two airplanes leave Kennedy Airport in New York at 11 a.m. The air traffic controller reports they are traveling away from each other at an angle of 103 degrees. The DC-10 travels 509 miles per hour and the L-1011 travels at 503 miles per hour. How far apart are they at 11:30 a.m.? Okay, we'll again start with a picture. There's no fixed orientation in this problem, so I'm going to let one of my trains go due east because due east represents the positive x-axis, and that's where we start our angles in standard position. And then the other plane is 103 degrees rotated from this, so 90 degrees is straight up. So this one is almost straight up, somewhere around there. Okay, then we've got some speeds given to us. The DC-10 is at 509 miles per hour. I will arbitrarily decide that that's this bottom one. And then the other one is 503 miles per hour. And it says how far apart are the two planes when they at 11:30 a.m. Okay, so 11:30 a.m. is half an hour after we started this scenario. So distance equals rate times time. We just need to do half of these rates, these speeds, in order to find the distances. So we'll fill in the distances here. Half of 509 is 254.5 miles. That's how far this guy is. And then the other one is half of 503, 251.5 miles. And so then I'll erase these arrows here at the end. These are stopped, at least at this one moment in time. We'll think of them as stopped. And then how far apart they are is the length of that last line segment. Okay, so we're trying to find the length of that last line segment. I will go ahead and label the vertices, the corners here, A, B, and C, randomly. And so we're trying to find over here this side, little b. And again, I like to use the law of sines if possible. Do I have an angle side pair? Let's say I have this angle, but I don't know what that side is. I have this side down here, but I don't know what this angle is. And I have this side, but I don't know what this angle is. So unfortunately, there's no way for us to get an angle side pair in order to use the law of sines initially. So we have to use the law of cosines. So using the law of cosines, we're going to use the only angle we have, which is the 103. So I'll fill in the ending part of the law of cosines. There's an equals here, and then something on the left-hand side. And I know the pattern for the law of cosine says whatever angle you put on the far right has to be the opposite side that you put on the far left. So this will be a b squared over here. Okay, b squared equals. All right, and then we'll do, we can call these two sides here little a and little c. And then we can fill in our law of cosines. So a squared, 254.5 squared plus 251.5 squared minus 2 times a times c. And then we'll just copy that cosine of 103 that we had before. And the nice thing about using the law of cosines when it's written in this form is that you can just type this whole thing in one shot. So let's try typing it in. Again, make sure you're in the right mode. My calculator is still in degree mode from the last problem, so that's correct. So if we've done all this right, then we should be able to hit enter and just get b squared in one fell swoop. So that's b squared. We need the square root of that thing. Oops. And we get about 396 miles apart. So that's our answer to this problem.